Learning objectives. We will discuss the following topics in this chapter. Introduction to neural computing and artificial neural network. Fundamental concepts. Biological neuron. Artificial neuron. Activation function and output function. Introduction to artificial neural network architectures. Applications of artificial neural networks. Introduction to neural computing and artificial neural network. Neural computing. Neural computing is an information process paradigm inspired by a biological system composed of a large number of highly interconnected processing elements, neuron, working in unison to resolve specific problem. Neural network. A neural net is an artificial representation of the human brain that tries to simulate its learning process. An artificial neural network is often called a neural network or simply neural net. Artificial neural network. Artificial neural network is an interconnected group of artificial neurons that uses a mathematical model or computational model for information processing based on a connected list approach to computation. The artificial neural network are made of interconnecting artificial neurons which may share some properties of biological neural networks. Artificial neural network is a network of simple processing elements, neurons, which can exhibit complex goal behavior determined by the connection between the process element and element parameters. Artificial neural network is an adaptive system that changes its structure based on external or internal information that flows through the network. Why is neural network? The conventional computers are good for fast arithmetic and does not what programmers program ask them to do. The conventional computers are not so good for interacting with noisy data or data from the environment, massive parallelism, fault tolerance, and adapting to circumstances. The neural network system helps where we cannot formulate any algorithm solution or where we can get lot of examples of the behavior we require. The neural network are based on parallel architecture of biological brains. Neural network architectures. An artificial neural network is a data processing system consisting large number of simply high interconnected processing elements as artificial neuron in a network structure that can be represented using a direct graph G, an order 2 tuple V E consisting a set V of a vertex and a set E of edges. The vertex may represent neuron input-output. The edges may represent symphatic links labeled by the weight attached. Example. The example is shown in the below picture. Vertex V is equals to V1, V2, V3, V4, V5. Edge E is equals to E1, E2, E3, E4, E5. Single layer fed forward network. The single layer fed forward network consists of a single layer of weights where the input are directly connected to the output via a series of weights. The symphatic links carrying weights connects every input to every output, but no other way. This way it is considered a network of fed-forward type. The sum of the products of the weights and the input is calculated in each neuron node, and if the value is above some threshold, typically 0, the neuron fires and takes the activated value, typically 1. Otherwise, it takes the deactivated value, typically -1. Single layer fed-forward network is shown in the below picture. Multi-layer fed-forward network. It consists of multi-layer. The architecture of this class of network, besides having the input and output layer, also have one or more intermediary layer called hidden layer. The computational units of the hidden layer are also known as hidden neurons. The hidden layer does not intermediate computation before directing the input to output layer. Multi-layer fed-feed network is shown in the below picture. The input layer neurons are linked to the hidden layer neurons. The weight on these links are referred to as input hidden layer weights. The hidden layer neurons and the corresponding weights are referred to as output hidden layer weights. A multiple layer fed-forward network with I input neuron, M1 neuron is the first hidden layer, M2 neuron is the second hidden layer, and N output neuron is the output layer is L minus M1 minus M2 minus N. Figure above illustrates a multi-layer fed-forward network with the configuration L minus M minus N. Recurrent networks. The recurrent networks differ from fed-forward architecture. A recurrent network has at least one feedback loop. Example: recurrent neural network is shown in the below picture. There could be neurons with self-feedback links. That is, the output of a neuron is feedback into itself as input. Application of artificial neural network. Clustering. A clustering algorithm explores the similarity between patterns and places similar patterns in a cluster. Best known application includes data compression and data mining. Classification pattern recognition. The task of pattern recognition is to assign an input pattern, like handwritten symbols, to one or many classes. This category includes algorithm implementations such as associative memory. Function approximation. The task of function approximation is to find an estimate of the unknown function subject to noise. Various engineering and scientific disciplines requires function approximation. Predication system. The task is to forecast some future values of a time-sequenced data. Predication has a significant impact on decision supporting systems. Predication differs from function approximation by considering time factor. System may be dynamic and may produce different results of the same input data based on system state, time. Artificial neuron model. An artificial neuron is a mathematical function conceived as a simple model of a real biological neuron. The McCulloch-Pitt neuron. This is a simplified model of real neuron known as threshold logic unit. The McCulloch-Pitt neuron is shown in the below picture. A set of input connections brings in activation for other neurons. A process unit sums the input and then applies a nonlinear activation function, that is, squashing or transfer or threshold function. An output line transmits the result to other neurons. In other words, the input to a neuron arrives in the form of a signal. The signal builds up in the cell. Finally, the signal discharges cell fibers through the output. The cells can start building up signals again. McCulloch-Pitt's MP neuron equation. McCulloch-Pitt's neuron is a simplified model of a real biological neuron. The equation for the output of a McCulloch-Pitt neuron as a function of 1 to n input is written as shown below. In this McCulloch-Pitt neuron model, the missing features are non-binary input and output, nonlinear summation, smooth thresholding, stochastic, temporal information processing. Artificial neuron basic elements. Neurons consist of three basic components: weight, threshold, and a single activation function. Artificial neuron basic element model is shown in the below picture. Weighting factors. The value W1, W2 to Wn are weights to determine the strength of input vector x is equals to x1, x2 to xn into t. Each input is multiplied by the associated weight of the neuron connected xt w. The positive weight exceeds and the negative weight inhibits the node output. I is equals to xt dot w is equals to x1 w1 plus x2 w2 to xn wn is equals to sigma ni is equals to 1 xi wi. Threshold. The node's internal threshold is the magnitude offset. It affects the activation of the node output Y as Y is equals to F into I is equals to F sigma Ni is equals to 1 XIW minus threshold K. To generate the final output Y, the sum is passed on to a nonlinear filter F called activation function or transfer function or squash function, which releases the output Y. Threshold for a neuron. In practice, neurons generally do not produce an output, unless their total input goes above a threshold value. The total input of each neuron is the sum of the weighted input to the neuron minus its threshold value. This is then passed through the sigmoid function. The equation for the transition in a neuron is A is equals to 1 by 1 plus expert minus x, where x is equals to sigma I AI Wi minus q. A is the activation for the neuron, AI is the activation for neuron I, Wi is the weight, q is the threshold subtracted. Activation function. An activation function f performs a mathematical operation on the signal output. The most common activation functions are linear function, threshold function, piecewise linear function, sigmoidal S-shaped function, tangent hyperbolic function. The activation functions are chosen depending upon the type of the problem to be solved by the network. Example. The neuron shown consists of 4 inputs with the weight. Neuron structure is shown in the below picture. The output I of the network prior to the activation function stage is shown below. With the binary activation function, the outputs of the neuron is Y threshold is equals to 1. Biological neuron model. The human brain consists of a large number, more than a billion of neural cells that process information. Each cell works like a simple processor. The massive interaction between all cells and their parallel processing only makes the brain ability possible. Biological neuron model is shown in the below picture. Dendrites are branching fibers that extends from the cell body or soma. Soma or cell body of a neuron contains the nucleus and other structures, supports chemical processing and production of neurotransmitters. Axon is a singular fiber, carries information away from the soma to the sympathetic sites of the other neurons, dendrites and somas. Muscles are glands. Axon hillock is the site of summation for incoming information. At any moment, the collective influence of all neurons that conduct impulse to given neurons will determine whether or not an action potential will be initiated to the axon hillock and propagate along the axon. Myelin sheath consists of fat-containing cells that insulate the axon from electric activities. This insulation acts to increase the rate of transmission of signals. A gap exists between each myelin sheath cells along the axon. Since fat inhibits the propagation of electricity, the signal jumps from one gap to the net. Nodes of Ranvier are the good gaps about 1 μm between myelin sheaths along axons are since fat serves as a good insulators. The myelin sheath speeds the rate of the transmission of an electrical impulse along the axon. Synapses is the point of connection between two neurons or a neuron and a muscle or a gland. Electrochemical communication between neurons takes place at these junctions. Terminal buttons of neurons are the smallest knobs at the end of an axon that release chemicals called neurotransmitters. Conclusion. In this chapter, we have covered the following in detail. Introduction to Neural Computing and Artificial Neural Network. Fundamental concepts. Biological neuron. Artificial neuron. Activation function and output function. Introduction to Artificial Neural Network Architectures. Applications of artificial neural networks.